Hello everyone. The goal of my second project was to use deep learning to identify cyclist risk factors in London. My supervisors were Majid Ezati and Ricky Natfani. As part of the introduction, I would like to introduce you for the main benefits of cycling, societal benefits. Those are essentially safety, economic, environmental, equity, and at the end, health benefits. It is known that the number of cyclists is very highly influenced by their perception of safety. So this means it's crucial to detect what are the risk factors present in our cities to make them feel safer. And to do that, it's very important to have a clear road safety indicators. They can be accident rates, injury rates, fatality rates, although the fatality rates were not considered here because the number of deaths usually per year are very low. Like in 2017, for example, there were 10 deaths. Apart from that, to detect these risk factors, it was used an Imagery dataset, and because the number of images is very high, it is very important to use some automatic method to detect objects on them and structures on them, so that we could correlate with the risk factors for object detection and using object detection and image segmentation. It was detected all those risk factors, and they were also ranked according to some statistics that were found. The overall goal of this project was to use, consequently, YOLO v5 and PSPNet 101 to extract cyclists' road risk factors from Google Street View images. The Google Street View images were already available previously, were extracted before using Google API from the researchers in the School of Public Health. The map of London was obtained from London Data Store. Everything was stored in RDS because there was some very high storage requirements. The number of points available were approximately 100,000 and 120,000. The number of images were 4 times more because there was 4 images for each data point. The number of LSOAs, this is like small areas of Greater London, were 4,000, and on average there were 100 images per LSOA. Some LSOAs with just 4 images, some small areas of Greater London, as I said, some with 844 images. So there was a broad distribution, so this means that for the LSOAs with less images, it can be somehow inaccurate to detect or segment these objects or structures. So it was used YOLO v5. It is a very recent model released in July 2020. The weights that were used for this model were the most accurate and heavy as well, but this was not a problem because we used HPC with some powerful GPU to execute this model. And the only detections with at least 0.5 certainty of accuracy were considered. Those are the methods, now are the results. Mostly it was detected cars in images. So in red, you can see all the objects that are associated with negative risk factors. So cars, buses and trucks. Buses and trucks were associated to the risk factor of the presence of heavy vehicles. Cars and parking meters were associated to the parked car risk factor, and the presence of people were associated to the pedestrians, the presence of bicycles to the presence of cyclists, and the traffic lights and stop signs to the presence of calming measures in London. So everything that I said now, it is on that graphic that I showed before with the different risk factors for cyclists in London. This is the distribution of each one of the detected objects across London. So bicycles were mostly detected in the city center because they are mostly used for short distances. Buses a little bit spread, although with higher density in the city center. People were mostly detected in the city of London because this is an area with a lot of working places. For instance, the number of cars were heavily distributed in the periphery of London, not in the city center. The number of trucks outside of central London because there are some restrictions in terms of their circulation, and stop signs and traffic lights a bit uniformly distributed, but mostly outside. I just want to highlight these histogram distributions on the bottom because it was seen that for buses and trucks, it was found a heavy long tail distribution. This means that For some LSOAs, we may find none of those objects, but for some others, we may find a lot. So this is an additional risk factor for cyclists. The heavy vehicles, as I said before. It was also part of correlation metrics. Here I would highlight the relation between bicycles and people, where you can find there is a close relationship between those two, but also between bicycles. In terms of negative correlations, the most important I would say is like between bicycles and cars, where we find a lot of cars. Usually we don't find bicycles. The same between cars and people, where we find cars. Usually people are not comfortable to walk alongside. So these were essentially two of the ones I wanted to highlight. These now we can see a little bit better this relation. Now I just want to highlight that it was not found an overall safety score for London. So I cannot say at this moment that this specific area is safer than any other. Although there was made a step forward in the sense that it was combined some of the atlas before in terms of positive risk factors and negative risk factors. So in terms of positive ones, we combine bicycles and people. Bicycles because it is known that as bigger as the number of bicycles, cyclists tend to feel safer, and in fact they are safer because the drivers are more aware of their presence. And the number of people as well, because it was found a negative correlation between the number of people and number of cars, and it's known that the number of cars to be responsible for the higher number of injury and accident rates with cyclists. And on the other side, on the negative side of this perspective, it was joined the heavy vehicles plus the number of cars. So this is a general overall traffic overview of Greater London. This was considered to be a negative way of looking at cyclist safety, considering these three atlas LSOAs. Image segmentation was also used. It was used Pyramid Scheme Parsing Network, PSPNet 101. It was a bit older, released in 2017. So it was chosen not only the most accurate model, but also with the one with better accuracy and speed and documentation. This is much heavy to execute, so this was split in 13 batches, the Google Street View imagery, and executed with a more powerful NVIDIA GPU. The distribution was mostly seen, so it was detected 200 billion pixels, mostly distributed. It was found a similar number of pixels distributed in the building, sky, and road categories. These may indicate that objects in any of these three areas may be found using object detection, and in fact they were. In buildings, they were detected plotted planes, for example. In sky, they were detected planes. In road, they were detecting all those objects that I referred previously, like cars, trucks, and so here cars appears in the 5th place, which makes sense. It was detected a very high number of pixels, which may be correlated with the fact that in the object detection, this was one of the most detected objects. And as future directions, I would highlight that the object detection can be used not only to detect the road safety in a cyclist perspective, but also to study the distribution of planes or even green areas in London. On the other side, it would be very important as well, not only to include static images, but also video, to be able to account for the variation in time of different risk factors or objects, such as cars, trucks. In the image segmentation perspective, although we segmented all the images, we didn't calculate road width, or sidewalk width, or we didn't look for the presence of street lights. Although after analyzing one image for every of the approximate 5,000 LSOAs in London, it was found that this is possible, and in fact this will be a great, very important to combine not only the object detection and the image segmentation in these perspectives to finally estimate the overall road safety score, which is the final goal of these studies.